Have you ever wished being alive during the time when humans first landed on the moon and experienced the first step of Neil Armstrong and Buzz Aldrin? But we are about to experience a new dawn of human space exploration. On May 30 of this year, SpaceX and NASA launched two astronauts, Doug Hurley and Bob Behnken, to the International Space Station under the Commercial Crew Program. And this was the first time that astronauts took off from American soil on American-made rockets since the last flight of Space Shuttle in 2011. This is not the first time for human spaceflight, then why launching astronauts to the ISS is such a big deal in 2020? And how SpaceX is going to revolutionize the aerospace industry. In this video, we'll take a deep dive into the past, the present, and the future of SpaceX. Well then, without any further ado, let's get started. SpaceX and NASA have been collaborating for the last decade with the goal of sending astronauts to space from American soil on American-made rockets. Generally, to launch a crew to space, a government organization like NASA will make the rocket, crew capsule, and all the hardware. But under this program, all the components are made by private companies like SpaceX and Boeing. Then how is this different from NASA contracting components of the rocket that they make to different companies? Well, in this case, NASA will not make any rockets. Private companies will do the designing, testing, assembling, software, the launching, which will create the safest and most economical rockets. NASA will only buy seats in these rockets to send their astronauts. The Crew Demo 2 flight was the last of the tests for SpaceX to prove its credibility of launching astronauts safely, and also as an aerospace company with technologies that can rival legacy space agencies. SpaceX has vertically integrated its rocket and satellite development. Almost all components are designed and made in-house. Rocket engine, fuel tanks, mainframe, guidance, software, which has reduced the cost and probability of delays. Their philosophy of rocket making is very different, about which we'll talk ahead in the video. As the astronauts returned safely on August 2nd with a splashdown in the Gulf of Mexico off the coast of Pensacola, Florida. This launch is the idea of democratizing space. Right now, NASA is the only customer for SpaceX. But in the future, many space agencies, private companies, and people with iron heart will be able to fly to space. Since its inception in 2002, SpaceX has been relentless. They keep improving their current rockets, creating outrageous concepts and building them from the ground up at mind-blowing pace. And we cannot keep talking about the company without mentioning its founder, Elon Musk. He's the real-life Tony Stark, genius, billionaire, meme lord, savior of mankind. If anyone has any doubts about what they will be doing in the future, here's what Elon said during an event.
What this heralds really is fundamentally a new era in spaceflight, a new era in space exploration. We're going to go to the moon, we're going to have a base on the moon, we're going to send people to Mars, and make life multi-planetary. And I think this day heralds a new age of space exploration. That's what it's all about.
And he and his team are the reason why SpaceX exists and innovating. We have to thank him for his efforts, genuine enthusiasm, and vision of colonizing Mars. So, thank you, Elon. For years and years in rocket launches, the first stage will help the rockets to lift off from the launch pad. And as it goes up in the atmosphere, multiple stages will be used to deploy the payload. But the one thing that is very consistent, and that is the complete wastage of these rockets. Components worth millions of dollars get destroyed. It's like flying a Boeing 747 from one place to another and throwing that $300 million plane away. It doesn't make any sense. Some might say, if the cost per launch is cheap enough, then why invest in an unproven reusable rocket technology? Why fix it if it ain't broken, right? Well, this would have been relevant before the age of reusable rockets. And if we talk specs and compare Falcon 9 and Falcon Heavy to other rockets, then SpaceX will win without much competition. Falcon Heavy, the most powerful rocket operational today, can reuse 90% of its parts. But there is also the second stage that can destroy. So the goal has always been to attain 100% reusability. Company or an individual cannot change the space exploration business without a unique philosophy. SpaceX doesn't think like the other players who have been doing this in the same old way for decades. I am not in any way saying that NASA is not doing its work properly. It was NASA who landed humans on the moon, made the Hubble Space Telescope to uncover the mysteries of the universe, landed the Curiosity rover on Mars, and many more. But on the other hand, there were projects like Space Shuttle program designed for ease of use and reuse, but in reality it turned out to be an extremely complicated machine, and these complications increased the time duration between launches. It was never able to achieve its full potential. The reason is the difference in philosophy of how to make a rocket. According to NASA, all the individual components should be analyzed and validated rigorously and put through its paces, causing a state of analysis paralysis. In contrast, SpaceX's approach is to do multiple tests and not being afraid of failing, then keep improving until the best machine is made. And especially, they are also not afraid of creating outrageous concepts. Have you seen the Starship? It's humongous. They have the confidence that if the science is right, they can make it. Falcon 9 is a pretty good example. When the vertical propulsive landing on a pad concept was proposed, it seemed as if it was science fiction. This is a scene from 1959 Russian sci-fi movie The Sky Calls. And this is 2018. Amazing. The family of Falcon 9 rockets defined what SpaceX is today. For their first successful payload deployment by Falcon 1 in 2008, NASA awarded a $1.6 billion deal to supply cargo to the International Space Station. It was in 2010 when we saw the first launch of the Falcon 9 version 1 rocket. It was very much different from the Block 5 of today. It had a 3x3 arrangement of 9 Merlin 9 engines compared to the Octave design. No landing legs, and unsuccessful attempts were made to recover the rocket's first stage using parachutes. In 2012, they became the first private company to successfully dock cargo capsules to the ISS as a demo flight, and later that year they started commercial cargo resupply missions. Falcon 9 version 1.1 in 2013 gave us the familiar form we know today. With a 60% performance boost over the version 1, data collected from this version helped us refine the landing leg deployment, boost back, atmospheric re-entry, controlled descent, and ultimately propulsive landing. It's 2015, enter the Falcon 9 full thrust. Using this, first re-entry and landing were performed in December of that year, and now operational and supposed to be the last iteration of the Falcon 9 is the Block 5. It has many incremental upgrades over the years, and this is the one that was used for the Crew Demo 2 mission. You know what else happened in 2018? we saw the introduction and the launch of the world's most powerful rocket operational today, the Falcon Heavy. With a payload capacity of 64 metric tons, it can lift more than twice the payload of the closest competitor, Delta IV Heavy. The rocket is 3 Falcon 9 engine cores strapped into one. The 27 Merlin 1D engines generate 22,819 kilonewton of thrust, launching the Tesla Roadster with Starman on board to space, blasting David Bowie's Life on Mars, and also the 2 boosters landing at the same time. It was indeed breathtaking.
You're breathtaking!
Talking about breathtaking, what's more breathtaking than an astronaut doing their spacewalks? To get astronauts to space, you need a crew capsule. And whenever we talk about a crew capsule, the first image that comes into our mind is the Apollo crew module or the Soyuz capsule from Russia. With them comes the image of cramped spaces, thousands of buttons and zero comfort. Now, if we compare them with the Dragon capsule, then in simple terms, it's the iPhone of all the crew capsules. Minimalist design, tons of space for astronauts, and 3 big touchscreens replace the buttons nightmare, and can carry 7 passengers. There are 16 Draco thrusters for altitude adjustments and 8 Super Draco thrusters for abort procedures, with liquid propellant on board, which can be a little bit nerve-wracking for some people, but the liquid propellant booster system provides many advantages over the solid booster system. A complete modern redesign of the spacesuits gives the astronauts a swag that we expect from Hollywood movies. New tech, like a single umbilical cord attached to the suits, can control temperatures, communications, audio systems, oxygen, nitrox for suit pressurization, etc. I mean, thank you SpaceX team for designing a crew spacecraft for the 21st century. So now we have seen what they have done in the past, but all of this wouldn't matter if they don't have anything freakishly good planned for the future. To start off, SpaceX went ahead, designed and made arguably the best rocket in the world, the Raptor engine, with full flow staged combustion cycle, chamber pressure of 300 bar, thrust to weight ratio greater than 170, and a reusability cycle of 50 flights. This is the new toy in their arsenal. Data from all the early tests shows us that this methane-powered rocket is almost ready to blast off to Mars. With only 2 attempts in the past to make full-flow staged combustion engines, Raptor is the only one that is operational today. It is needless to say that this is an engineering marvel, and these Raptor engines will be used in the Starship that will be taking humans back to the moon. And if all goes according to plan, to Mars we go! Now let's solve the mystery of space cowboys in Boca Chica. Well, they are making prototypes for SpaceX's most ambitious project ever, the Starship, a completely insane behemoth of a rocket that, when complete, will be transporting a large number of people to and from Mars. First mentioned by Elon Musk in 2012 as the Mars Colonial Transporter, renamed to Interplanetary Transport System 2015. Big Falcon rocket 2017, and in 2018 it was finally named as Starship. During this time, the concept also went through many significant technical and structural changes, like the shift from carbon composite to stainless steel, which will provide better thermal resistance and structural versatility. The number of fins went from 3 to 2 for better aerodynamic control. The diameter of the rocket finalized at 9 meters over proposed 12 meters, and many more. SpaceX is leveraging all of its experience in the field of rocket building and reusability. Starship will be the first rocket in the history to be 100% reusable. Yes, there have been many concepts that claim to do that, like the single stage to orbit STOs, but only concepts. The Starship is made up of two stages. First stage, or the booster, known as the Super Heavy, with 31 Raptor engines churning out 72 meganewton of thrust. And the second stage, or the upper stage, is the Starship spacecraft. It has integrated payload section and also capable of transporting humans to orbit, planetary destination, and also different places on Earth. With a payload capacity of 100 plus tons, Starship will speed up our dream of being a multi-planetary species. As of today, they are making and testing multiple prototypes of the Starship. The first test was the Star Hopper, and on August 4th, their SN5 prototype successfully performed a flight from one pad to another with a 150-meter ceiling. Multiple prototypes will provide precious data that will be used to solve problems, improve and refine the Starship. And this is the approach that separates SpaceX from others. Since 2002, especially after 2008, SpaceX has always been considered a disruptor. And now that we witness this change, it will not be a wild guess that in future, anyone with legacy infrastructure will be deemed obsolete. During the last 18 years, they made technological advancements that used to be considered as impossible. I'm reiterating this. Reusability is the future of space exploration, and SpaceX is moving fast towards this bright future. The type of advancements we see today in rocket technologies is dependent on the drive to make the impossible possible. The argument is not about the availability of money and facilities, it's also about dreams and ambitions. We landed humans on the moon in 1969.
It's one small step for man, one giant leap for mankind.
Saturn V rocket used was overkill for a manned mission to moon, as the people who designed and built it had the dream of colonizing Mars. Since then, several designs and prototypes were proposed, many delayed and ultimately got cancelled. As Elon once said, if a design is taking too long, the design is just wrong. These rapid investments and development towards colonizing Mars are inspiring, and we are about to witness the dawn of interplanetary civilization. So now, if someone asks you, how SpaceX will revolutionize human space exploration? Well, now you know the answer. Also, share this video with that person. If you learned something new, please like and subscribe and hit that bell icon so that next video from me will just slide into your notifications. And thank you so much for watching.